This is lesson 2.2.4. It's called Can I Show It Another Way? And we're talking about expressions. And we met Cecil in a previous lesson who's walking on a tightrope and going a certain distance, and we're showing those as expressions. So if you look at this expression here, we have 7 plus 7 plus 7 plus 7, and then plus -5 plus -5. So a bunch of 7s, a bunch of -5, repeated addition. When we're calculating something like this, and there's a number being added over and over and over again, is there a shorter way to write this? So this is what we're going to look at in today's lesson. Okay, so here's Cecil on his tightrope. He wants to go 6 feet in the tightrope. The tightrope is 6 feet long, and he wants to go across it. Okay, so 6 feet from one side to another. Using only the lengths 5 and 8 feet, can we find two different ways where Cecil can reach the end of the rope, go to the ladder, and do his routine? Okay, so we are going to first let's set this up. This is lesson 2.2.4. And we're still working with integers. So problem number 67. We have a tightrope that is 6 feet, and we can only use 8 and 5. Okay, so our tightrope is 6 feet. So what can we do? The distance from A to B. Here's A, here's B. That's 6 feet. Okay, so to get them over. All right, so one possible answer is we can go 8 feet this way, and then 8 feet this way, and then we go 5 feet this way, and 5 feet this way. Okay, so that means we had gone 16 feet to the right, 10 feet to the left, and that expression would be 8 plus 8 plus -5 plus -5. And this expression would get a 6. Is there a different way that we can write this? We have 8 plus 8, and we have -5 plus -5. And another way would be by using multiplication. Okay, so multiplication would be, this is 8 and 8, so that's 2 times 8. And then we're going 5 and 5, so that's 2 times -5. Okay, so we're grouping them. Okay, so 2 groups of -5, 2 groups of 8. So that's one possibility. Okay, now another possibility is we can do this. We can go 8 this way, and then 5 this way, and then 8 this way, and then 5 this way. Okay, so if we're going 8 and -5, that's 3 now, and then 8 and -5, that's another 3. Okay, so what does this look like as a numerical expression? And this would be 8 plus -5 plus 8 plus -5. Okay, so that's a little bit different from this because we're looking at the routine that that Cecil would do. And if we do 2 groups of 8 and 2 groups of 5, that just means he's doing 8 twice, and then he's doing -5 twice. But in this one, what is he doing more than once? He's going this way and then that way, and then he's doing it again. So that's what he's doing twice. So he would have 2 groups of 8 plus -5. So 2 groups of 8 plus -5. Okay, so there's a subtle difference between these two, but it'll give you the same result. Okay, but when you're looking at this routine, when Cecil's going to the right, the same amount, and then to the left, it's different from right, left. Okay, so the routine is different, but the total distance is the same. So either will get him there. Okay, so this is basically what we're going to be doing today. So you have this expression. So Cecil is so good at crossing the tightrope that he can make a leap of 7 feet at a time. He crosses the rope in the leaps that are shown. So what are two ways that we can show this? Okay, so we've got, first of all, this is number 69 in the book. And so Cecil does this. 7, 7, 7, 7, 7. All right, so two different ways that we can show this. All right, so the first one that you might have done was he has 5 leaps of 7, so 5 groups of 7. Or we can do the repeated addition, 7 plus 7 plus 7 plus 7 plus 7. So both of these are numerical expressions that would show this. Okay, so that's 35 and that's 35. So that gives them a distance of 35. So both of these will give the same result. Okay, so we're looking at the repeated addition and the multiplication as two different expressions. Now, when they're asking which is easier to record, is it easier to be repeating these addition steps over and over and over again, or just to write, well, I got 5 sevens, 5 groups of 7? And the answer would be this one is a little bit easier, right? This one is easier. Okay, now on the next one, how did Cecil, the tightrope walker, move if he started at point A and his moves were recorded as the expression 6 times 6.2, 3 times 6.2 plus 2? And we're going to draw a diagram of this to see what he got. Okay, so this is number 71. We have 3 and that and that. Okay, so how would we draw this diagram? All right, and what you should have come up with is first, he's going to do something 3 times. He's going to go this distance 3 times. That is not a distance of 3. 3 groups of 6.2. So his first step is going to be 6.2. Then his second step, or leap, is going to be 6.2. And his third step is going to be 6.2. Okay, so the way we would say this is kind of new to our vocabulary, is we would say 3 groups of 6.2. Okay, and this is kind of our new vocabulary. Groups of. The parentheses means 3 groups of 6.2. Okay, and then his last step is going to be 2. Okay, so how far has Cecil traveled? Well, we got 6.26. That's 18.6 plus 2. So he has traveled a distance of 20.6 feet. 20.6. Okay, and the let's look at our next question. Imagine Cecil, the tightrope walker, starts at point B and walks the tightrope towards point A. How should this be written, and can we write it in more than one way? So let's go ahead and draw that one. This is number 72. So he starts at point B. Here's point B, and he goes -3, -3, -3, -3, -3. All right, and what we should have figured is, well, this is a repeated addition again. I'm going in this direction. That means I'm adding negatives. So one way to say that is -3 plus -3 plus -3 plus -3 plus -3. And what is the quicker way? We have 5 groups of -3. 5 groups of -3. right? 5 groups. So that means when we're drawing 5 groups of -3, you'll still get the same product than if you switch those numbers, but this diagram specifically says we're doing 5 things. We're doing 5 moves, and we're doing -3 every single time. All right, and how far has he gone? He has gone -15 in the end. So let's move on to the next one. He does end up, okay, so we got that. To represent 2 parentheses 3, Chad drew the diagram. According to that, based on what Chad did, how would you predict that he would draw 5 with -3 in parentheses? And what is that expression? All right, so let's start with what Chad had. This is number 73. He's got this here, and then he had them circled, and the circling indicates that these are 2 groups, right? Okay, and so this is 2 groups of 3, right? 2 groups of 3. All right, so how would we show this here? So how would we show this? All right, so what you should have come up with is, if we're trying to figure out how many groups we have, we look at first what's in the group. This is in the group. This is what we have groups of. So we have 5 groups of -3. So we should have 1 group of -3, 2 groups of -3, 3, 4, 5. Okay, so 5 groups of -3, which equals, what does this total value give us? -15. 5 groups of -3. Okay, and notice this is not 3 groups of -5, even though that would still give you -15. We don't have 3 groups. We don't have 5 in each group. So make that connection. Okay, how many groups we have and what we are putting in each group. All right, let's move to the next. Okay, so we're going to see if we can use these concepts and solve some problems. So 2 equal expressions can be represented with the diagram at the right. We're still on page 11. Don't turn the page. So draw similar diagrams for each of the expressions in parts A and B, and what is this going to look like? Okay, so our first one, this is number 74. We have this. And then we're going to have this. So right off the bat, we can see that there's some similarities here. Okay, so one of the similarities are these are using these have the same numbers. Okay, it looks like they kind of are using the same digits. So that might be a little bit confusing. But what's different here? What's different is what's in the groups. Okay, so same digits, different groups. And this is a key part here, okay, of what's in the group, because we need to find out, well, how many groups do we have there, and let's draw them. Okay, so let's start with the first one. What does this drawing look like? Okay, so what you should have is we have 2 groups of 3 plus 5. Okay, that's what we're going to draw. So let's first look at what does one group of that look like? Because if 2 groups are there, we just duplicate our first group. Okay, so our first group has 3 plus 5. There's a 3 and there's a 5. So two groups of 3 and 5 look like this. Two groups of 3 plus 5. And what is that value? Well, I have 3 and 5, that's 8, and then 3 and 5, that's 8. So that equals 16. Okay, now this one, are we going to get the same amount? Well, let's see. So we have two groups, but what's in each group? Two groups of 3. So that looks like this. We have a 3 and a 3. So you see the difference between this is all about what's in the group. So two groups of 3, there's one group of 3, two groups of 3, and then we add a 5. So they don't have the same value. This one has a value of 3 and 3, which is 6, plus 5, which is 11. So not the same value. Okay, so for this next part, we're going to, we already compared them and contrasted them, so now let's look at this part. So we have negative 3, and then this in parentheses, that in parentheses, and 3 like this. So let's go ahead and put that, and then we can talk about it. Okay, this is number 75. Okay, so we have 3. And then plus negative 4. And then we have, we'll leave this space for the diagram. And then we'll have 3. And the bracket is just like a parentheses that we use when we have other parentheses inside. Negative 2.5 plus negative 4. Okay, so we can see looks pretty similar. Looks the same. So how would these diagrams be different?